Completing the square is a technique that forces all quadratics to be factorable. We use completing the square when we have a quadratic equation where we see x twice. We have an x squared term and an x term, and the quadratic is not factorable. There's 5 steps to completing the square. I'm going to start with an example where we start at step 2. Example 2 will come back and fill in step 1. But for now, we're going to start with step 2. Step 2 is write the left side of the equation as x squared plus bx. We want our x squared term plus our coefficient times x with no constants. So if we look at our first example, our x squared term is already on the left. We don't have an x squared term on the right. But we need to bring this 13x over to the left. So I'm going to subtract 13x from both sides of my equal sign. And I want to get rid of this plus 20 by subtracting 20. Subtracting 200. Combine my like terms, x squared minus 30x, leave a space, equals negative 243. Step 3. Add b divided by 2 squared to both sides of my equal sign. In this case, b is negative 30. So I'm going to add negative 30 divided by 2 squared to both sides. Negative 30 divided by 2 is negative 15. Negative 15 squared is 225. Equals negative 243 plus 225. Negative 243 plus 225. Negative 18. Now adding in 225 to the left side has made the left side factorable. That's step 4. Factor the left side. So I have a trinomial that I'm going to factor into the product of 2 binomials, x and x. And 225 is a perfect square. 225 is 15 times 15. And I want positive 225, so both of these 15s can be positive, or both of these can be negative. In this case, I want them both to be negative, so I can get a negative 30. If you notice, I have x minus 15 times x minus 15, which can be simplified down to x minus 15 squared. Which leads me to my last step. By rewriting this binomial as a this binomial times a binomial as a binomial squared, I only see x once in my equation. And since I only see x once in the equation, I can solve for x directly. Forcing this to be factorable is the piece that allows completing the square to work. I can now take the square root of both sides, and since I added in the square root, I need a plus or a minus. So I have x minus 15 equals plus or minus, I'm going to rewrite negative 18 as 9, 2, and negative 1. X minus 15 equals plus or minus 3 square roots of 2 I. Add 15 to both sides of my equation, and I get my two answers. X equals 15 plus 3 square roots of 2i, or x equals 15 minus 3 square roots of 2i. Looking at example 2, the difference between example 2 and example 1 is my x squared term. In my first example, my x squared term had a coefficient of 1. In example 2, I have a coefficient of negative 4. So my a term, the coefficient of my x squared, is negative 4. So step number 1, before I want to start any of these, is to divide both sides by a. And what is a? Well, a is my coefficient of x squared. So in example number 2, I want to divide the left side by negative 4, and I want to divide the right side by negative 4. So negative 4 divided by negative 4 becomes 1, and I just have 1 x squared minus 5x, leave a space, equals negative 13/4. Now I need to start with step 2. I need to write the left side as x squared plus bx. Well, if I look, I already have that. I have my x squared term on the left and my x term with all my coefficients on the right. So now I need to add negative 5 divided by 2 squared to both sides. So I have x squared minus 5x plus negative 5 divided by 2 squared. Well, I can take this squared and distribute it over this division sign. So I have negative 5 squared divided by 2 squared. Negative 5 squared is 25. 2 squared is 4. Now I can factor the left side. X and x. And I need two things that multiply together to give me 25/4. Well, 25/4 is kind of like a perfect square, because 25/4 is 5/2 times 5/2. 5/2 times 5/2 is 5 times 5, 25, over 2 times 2, 4. And I have a positive 25/2, so I can either make both of these positive or both of these negative. In this case, I want them both negative. Now if I think about it, 5/2 is 2.5. So if I FOILed this back out, I would have x squared minus 2.5x minus 2.5x. Minus 2.5 minus 2.5 does give me negative 5. And if I multiply negative 5/2 times negative 5/2, I do get positive 25/4. So this left side is factored correctly. On the right side, I have negative 13/4 plus 25/4. They both have common denominators. So I can just add my numerators. Negative 13 plus 25 gives me 12. And 12 divided by 4 is 3. And now I need to rewrite my left side as x minus 5 halves squared. Once I'm here, I only see x once, so I need to take the square root of both sides. X minus 5 halves equals plus or minus the square root of 3. Now I need to add 5 halves to both sides, and I get x equals 5 halves plus the square root of 3, or x equals 5 halves minus the square root of 3. Now I can leave my answer like this, or I can combine these two into one fraction. My denominator is 2, so my common denominator would be 2. And if I put a 2 down here, I have to have a 2 up here. And if I put a 2 down here, I need to have a 2 up here. So I could rewrite my answer as 5 plus 2 square roots of 3 over 2, or 5 minus 2 square roots of 3 over 2. Either answer would be acceptable.